Today we're going to break down a story about technological pride, a seemingly tiny fix for comfort, and the absolute catastrophe that followed. This is the story of the 1998 Esheday train disaster, and believe me, it's a chilling lesson in the world of high-speed rail. So picture this. It's just a totally normal morning in Germany. We're on the Intercity Express 884, the pride and joy of German engineering, just gliding along from Munich to Hamburg. Inside, you've got 287 passengers just settling in, not a care in the world. But for George Dittman and his family, sitting there in the first carriage, that ordinary morning just shatters. In a split second, a huge, jagged piece of metal just erupts from the floor. It's the very first terrifying sign that something has gone horribly, horribly wrong. And you've got to remember, this is all happening at an insane speed. The train is rocketing along at 200 kilometers per hour. That's about 125 miles per hour. At that velocity, there is zero margin for error. Absolutely none. Okay, so how could one single piece of metal trigger the deadliest high-speed rail accident in history? Well, the answer is a devastating and unbelievably fast chain reaction. That piece of metal George Dittman saw, it was a fragment from a wheel that was literally disintegrating. As it dragged along under the train, it was like a ticking time bomb. Just moments later, it snagged a track switch and flipped it like a lever. This created a fork in the tracks right underneath the speeding train. The front cars, they passed over it safely, but the third carriage was violently yanked sideways, tearing the train in two. It slammed into a bridge pillar, bringing the entire 300-ton structure crashing down, and the rest of the train just plowed one car after another into a wall of concrete and twisted steel. The force of that impact, it's just unimaginable. The carriages that were right under that 300-ton bridge, they were crushed down to a height of just 6 inches. 6. Rescuers who got to the scene were just met with total, complete devastation. And this really brings us to the biggest question of all, right? The Intercity Express wasn't just some train. It was held up as the safest in the entire world. To figure out how this could possibly happen, we need to rewind a bit, back to its creation. All right, so the ICE was Germany's big answer to Japan's Shinkansen and France's TGV. This thing wasn't just a train, it was a masterpiece of 1980s engineering, a massive source of national pride. I mean, everything about the IC was top of the line. It was sleek, aerodynamic, fully computer-controlled, and the passenger comfort was just second to none. It was, by all accounts, the absolute pinnacle of railway tech. But as any engineer will tell you, perfect is, well, it's an illusion. And hidden inside the ICE's design, a search for even more comfort had introduced a single fatal flaw. The problem and the so-called fix, it all came down to one single component: the wheels. This is where a tiny little annoyance snowballed into a monumental disaster. So the original IC trains used what are called monoblock wheels. Simple concept, they're forged from a single solid chunk of steel. Incredibly strong, incredibly reliable, but they had one small problem. As they wore down, they'd create these vibrations that would, rattle the glasses and cutlery in the dining car. A minor inconvenience, sure, but it was one that engineers were dead set on solving. So, to fix this little comfort issue, they brought in a new design from slower-moving city trams, the resilient wheel. Instead of one solid block, this wheel had an outer steel tire, but it was separated from the inner hub by a thin 20mm rubber damper. That rubber was amazing at absorbing vibrations, making the ride beautifully smooth and quiet, but it also introduced a catastrophic hidden danger. And that danger is a principle called metal fatigue. See, with every single rotation at high speed, that thin outer steel tire would slightly compress and then expand. This was happening 500,000 times a day. Over time, all that stress creates tiny microscopic cracks in the steel. And here's the tragic part. The very same rubber damper that made the ride so quiet also completely masked the sounds and vibrations of the metal cracking. There was no warning at all that the wheel was about to fail. And this is where the story goes from being a tragic accident to a truly preventable disaster. Because the failure of that wheel, it didn't just happen out of the blue. There were so many warnings. I mean, as far back as 1992, a top German research institute warned that this wheel design might not be safe for high-speed travel. Then, just a year before the crash, the tram company in Hanover, using the same wheels at much lower speeds, found fatigue cracks and they reported it to the National Railway Deutsche Bahn. That warning was ignored. And here's the real kicker. Maintenance logs showed the very wheel that shattered had been flagged for defects 8 different times, and it was never replaced. To make matters even worse, Deutsche Bahn actually owned crack detection machines, but they didn't use them routinely. And the justification? Get this. They gave too many false alarms. So instead, they sent technicians out with flashlights to do visual inspections, a method that had absolutely no chance of spotting the microscopic cracks growing deep inside the steel. Well, as you can imagine, the fallout from the disaster was immediate, it was immense, and it forced a complete rethink of safety across Germany's entire rail network. The human cost was just staggering. 101 people lost their lives, and that includes 2 railway workers who were on the ground. Another 88 were seriously injured, and about 100 more had minor injuries. All told, nearly 300 people became victims of this crash. To this day, it is the worst high-speed rail accident in history. So when you really break it all down, it was just a perfect storm. You had a design flaw that was vulnerable to metal fatigue. You had a systemic failure where people ignored warnings and didn't inspect things properly. And all that led to the primary technical failure. Each mistake just enabled the next one, leading right to the final catastrophe. The legacy of Escheded is written in new safety regulations. Every single ICE train was immediately switched back to the original solid monoblock wheels. They changed the infrastructure, redesigning bridges near track switches. Even the pressure-proof windows, which had made it harder for rescuers to get in, were replaced. And today, the Escheded disaster is a required case study for railway engineers, a permanent, hard-learned lesson on the price of complacency. And that really leaves us with a huge question, doesn't it? In our constant push for progress, for technology that's faster and smarter and more comfortable, how do we stop ourselves from being blinded to catastrophic risk? The story of Escheded is a really sobering reminder that sometimes the smallest change, made for the most simple reason, can end up having the most devastating consequences imaginable.